There's a lot to learn with making background transactions efficient, but the good news is that Android gives you the Sync Manager framework that implements many of these best practices. You utilize that framework by implementing a sync adapter. The framework, originally introduced in Android 2.0 Eclair, or Android API Level 5, allows Android applications to leverage the same basic framework that Google apps use for efficient synchronization. Ultimately, it's a centralized place to put all of the device data transfers in one place, so that they all be scheduled intelligently by the OS. In other words, that's one big cookie. Android Sync Manager handles synchronization requests using SyncAdapters. The Sync Manager batches and time shifts these requests when possible to allow your data transfers to be scheduled with transfers from other apps, all working towards the goal of reducing the number of times the system has to switch on the radio. If your device has less memory, it will schedule fewer simultaneous syncs. The Sync Manager also takes care of things like checking for network connectivity before initiating transfers and retrying downloads when connectivity is dropped. The synchronization framework works with content providers for two-way synchronization and leverages the Android Account Manager to provide synchronization services that are tied to accounts. Our application will do neither of these things, but will still have to deal with some of the complexity of these features. This can make SyncAdapters seem daunting at first. What does the Sync Manager do to help you fetch data from the network? Does it schedule your network jobs with other apps, implement a synchronization protocol, store account information, or has logic to retry your request? Select all of these that match.